right. Could everyone see my screen?
Yeah.
Great. So yeah, as Ian said, my name is Mohit. I'm from New Jersey, the East Coast. It's night here, 9 o'clock, but I'm energetic, ready to give this presentation. So I'm uh, I'm as nervous as I would be. This is my first time giving a virtual presentations, but I'm still as nervous as I would be if I was doing it in person. Um, So thank you, Ian, for the opportunity. My presentation is about how do you test channels and flows. So I'll speak to you about, I'll present to you a use case. So I'm an Android engineer, so these use cases will be from an Android perspective, but they still illustrate the concepts, what the features in the coroutines testing library. So, and I'll show you like how to do flow assertions. I'll show things on the flow. I'll show you lastly testing pattern using the coroutines library itself, which is very different and interesting. So let's start. So suppose you're building an app, and I'm trying to suppose you're tasked with building an app that displays user details. And how do you go about doing that? And suppose like API gives you an endpoint on Android, like you may have these two components, like a repository that communicates with the API, and then your view model that takes the data, processes it, and displays it in the UI. And you may how do you implement these two components? And let's first start looking at that. So this will also give you a good background if you haven't used flows or channels. So suppose an API gives us an endpoint, like the API team gives us an endpoint to get user details, and we pass in an ID and we get user details back, and we process it using JSON or Mashi or whatever JSON library, serialization library. So one way you could implement this is that you could use retrofit, popular library, for implementing asynchronous requests, and it has this concept of you can specify all your endpoints in an interface, and using annotation you can specify what URL you're going to hit, and it provides support for suspending functions, so it knows what the suspending method is in its interface, and it will asynchronously make the API request like in a separate thread for you. And when you look at this, it looks like a regular function. So if you haven't used coroutines before, the benefit of coroutines are a type of method, like stands for cooperative routines, or routines is another word for methods. So, and what's special about them is that they have the ability to suspend themselves, which is not a feature in regular methods. So this method here will make the API request as a suspending method. And the way you would implement this, if you're using Android, how do you make this API request in your repository? So I have a class for that, and I'm injecting in my API service in there. And the reason I'm injecting in there because I want to be able to do for testability, as you'll see. And I have a method for getting the user details, and the method's return type is a flow of an actual result. So this result type here in the flow, when you look at that generic, so in Kotlin now they added this result type, which is like allows you to specify the result of some computation. It has really nice helper methods for determining whether it was successful or failure. And I'm specifying that this result will be my user details, POJO or DTO. So how do we go about creating this flow? So in the coroutines library, they provide this flow method, which takes in a Lambda block, and it has a receiver of the flow collector. And what the flow collector allows you to do is specify how you're going to emit things. It has an emit suspending method, and you could use that to emit some particular value. And I'm going to use that in this repo, and I'm going to say to my API service, hey, get me the user details for some particular ID that I'm passing in, and I get the result back, and I'm going to emit it into this result. When the result.success, success is a method provided by the result class, and I could wrap my data with it and emit it. So I have right now a flow emitting the result. of user details. So how do you like do this on a separate, so the API request is happening on a separate thread, but suppose you had, the advantage of like doing it this way using flows is that it provides you with operators like map, flat map, and makes things much more functional, and it provides like operators for retrying, catching errors, as we'll see. And suppose that I want to specify like, what thread will this flow block run in? And when I say that, what I mean is what thread will the emit run in? And I could use this method, use this extension on a flow called flow on, and it takes in this thing called a context. So what is a context? A context is something that could be tricky if you're new to coroutines. And a context represents basically you could think of it as a set. It's not implemented as a set underneath the hood, but you could think of it as that. And it's a set of elements that describe the configuration of the coroutine, and it has things such as the job, the dispatcher, etc. So to specify that I want this flow to run on some context, I'm going to say I'm going to utilize this thing in the coroutines library called the dispatcher. And if you're familiar with RX, is very similar to schedulers. So it allows you to, so it has just similar to scheduler.io in RX. It has like default IO, main, etc. So I want to run this in the IO dispatcher. How do I do that? So in the flow, I'm going to add a call flow on, and I'm going to pass in the dispatcher that I want to run it on. So if you could use either Coin or Dagger or some dependency injection framework to basically specify what type of dispatcher you want to put in, if you're using Dagger, you create a module for that with the name qualifier of dispatcher.io and then pass it in here. So I'm specifying here that I want this flow block to run on this dispatcher. So what happens is that everything above this flow on, I could have any type of operators like map, flat map in there. They will run on this dispatcher. Everything upstream will run on this dispatcher. Everything downstream will run on the dispatcher that you call this coroutine, that you build your coroutine on. And I'll show you what I mean by that more. So this is what our repository in the end looks like. It's very simple, and we'll add more specification to this and make it a bit more complicated. So I'll show you that later. So now we have a repo which gives us a flow of some data, and how do we consume it? And want to display it to the UI. And there's we use on view models. So there's the architecture components library. Google provides this library, architecture components. Will provides you lots of classes and tools to help you better build your apps. And it has a view model that you could inherit from, and it has a lot of features. And inside of this view model, so I created a user details view model. And in order to read from my flow or from my repo, I need to create a coroutine. And the question is, how do you create a coroutine? So to create a coroutine, you need two things. One thing you need is a scope. And there's a constructor, there are many different ways to create a scope. There are scopes provided to you by the coroutines library. There's a scope provided to you for like doing global things like global scope, but it's not recommended to use that. So I'm over here in this example, I'm creating my own scope using this coroutine scope constructor. And what it takes in is the context. And what I'm going to pass in for my context, I'm going to say I want this scope, this coroutine, to be run on this scope and to run on this main dispatcher. Obviously, I want, in Android, you want your vModel to work on the main thread, and anything that's network requests are on happens on a separate thread. So I have a coroutine that will run on the main dispatcher, and I'm going to launch my coroutine and start my coroutine by calling scope.launch. And inside of that Lambda block is where I specify the work that I want to do in my coroutine. So what I want to do is that I'm going to pass in my repository. I'm going to inject it in for testability. And when I inject it in with my repository, I'm going to tell my repository, hey, give me the flow, the user details flow. So when I grab the flow here, keep in mind that it doesn't start, executing the code in the flow block. It would only do that when I read from it. So the question becomes, how do you read from a flow? So how do you subscribe to it? So in coroutines, it has this concept of a collect flow collection. It has a collect method in there, and it's a lambda block, as you can see, suspending lambda block, and it has a parameter value of type T, and it gives you the value. So every time your flow emits something, it will like call this method, and there will emit the value, whatever value that it's sending. So when the flow.collect, it will give me the result in that lambda block. And then I could take that result and then tell my UI to render it. Or you could, if you're using this concept of this construct called live data in architecture components, you could say to it, hey, here's my data. You could push to it, and then it will render it to the UI. Or now they added in coroutines library this state flow, which is similar to live data, but it has multi-platform support. It will have that's the benefit of that. So with Stateflow, you could basically also it's also push this data that you get from your flow, and the UI could be like listening to that state flow. So one implementation is if you're using like an MVI model view intent type of framework. One way to like do it is to inject your reducer into your view model, and then you dispatch the state. State is basically this data that you get back. So this is one way that you could do this if you're using MVI. And this is how our view model looks in the end. And it's basically, it's a very simple implementation. Is basically getting the user details and giving it to some other class or the UI to display it. So now, so one more thing is that in this example, when I created my coroutine, I created a scope by myself, but this architecture components library, they create a scope for you. It's called view model scope. It's a property delegate on a view model, and it sets the dispatcher for you, and that you could utilize. So it does it for you, and it handles a lot of things in terms of lifecycle management. So that's the benefit of that. And we have a very simple use case that you from an Android perspective of a repository and view model, these two components. So how do I unit test each of them? And let's look at that, and let's start with unit testing our repo. So, the coroutines library, testing library, in order to use that, you use this URL, like you put it into your build script with some specific version, and then it provides you with a scope, a dispatcher, just for running tests for you. It creates it for you. It provides these things, and also provides you with like a method for testing delays, like run blocking tests, for example, is a method that it provides that you could use that I'll show you. So there is also an Android specific version of this that provides you with the main dispatcher, like for testing, and I'll show you that. So what we want to test are 3 different use cases, like for a repository. We want to test the success case, the simplest case, that flow actually emits some result. And then we also want to test error handling, right, which is important. And how do we like handle errors in our repo and test that. And lastly, I'll show you a much more advanced one where we basically, how do we handle this concept of like, how do we handle retries with some delay? So let's start with the simplest example of handling a flow with the success. So here I have my repo, and it's taking in 2 things, and I'm injecting it for the purpose, and I want to be able to mock out, and inject mocks. So first thing that you need to do every time you want to test something coroutine later, you have to create a coroutine like for your test. Because so I'm creating a coroutine using run blocking. The run blocking method is a method provided to you by the coroutines library. It creates a coroutine internally, and inside of this lambda block, you specify what you want your coroutine to do, and it blocks until the coroutine completes. So I'm going to utilize this method for my test. So the first thing that I'm going to do is that I'm going to create a user details DTO, and I'm going to mock out my API service. But as I showed you before, this API service was an interface, and it has a suspending method user details. So the question is like, how do I mock out, stub out my user details, suspending method? And if I were to do this, so another thing I forgot to mention is that I'm using a library here called Makito Kotlin, which you may be familiar with. It provides you with really Kotlin idiomatic ways to do mocking, to do stubbing, and mock API service that I'm using there is a method that it provides for mocking. And inside, you could use a Lambda block, and you could stub out methods in there using on, and then whatever method you want to stub out you could say do return something. So I'm doing on user details for ID of one, return me user details, DTO. But what happens is that when I were to utilize this, I get an exception that a suspending method can only be called from another suspending method. And this is important to know because the suspending method could only be called from another suspending method, right? Not a regular method. So when you look at, the signature of that on method, it takes in a lambda, and that lambda, it doesn't have a suspend keyword. That's one problem here what we have here. So Makito Kotlin provides you with a really nice helper method, and another method called unblocking, and it has a suspending lambda, and I can utilize this internally. When you look at it, it's also creating a coroutine using run blocking, and it's doing Makito when, so it's stubbing it out for you. So this is the benefit of using Makito Kotlin. It provides you with this method. There's another library called mock-k, which also provides you with much more coroutine support that you could use. So now, right now in this slide, I have mocked out, stubbed out my API services user details method. It gives me some actual data. So the next thing that I need to do is that first, so I'm going to move all that out into a mock user details method to simplify my slides. So next thing I'm going to do is that I'm going to create a test coroutine dispatcher that I'm going to inject in my repo, as you saw that I had. And I'm also going to inject in my mocked user service. And I'm going to grab the flow. The next thing that I need to do is that I need to basically collect from this flow, and then I need to do an assertion. So, so what I showed you before, the way I was collecting was by doing flow.collect. Collect is a type of terminal operator, and but another terminal operator is called single. And a single guarantees that your flow returns one item. If your flow returns more than one item, then it will throw an exception. So here I'm doing flow.single, giving me that result, and I'm going to check that result.isSuccess. IsSuccess is a method that's provided to me on that result type by the Kotlin language, by the library, and then I'm doing assert true. So this is a very simple test of the success case where I'm basically, getting data from my repo and then just asserting on it that I actually get some actual data. So the next use case is a bit trickier. It's about how do you test flows, how do you test errors? And when you look at the repo, the implementation that I had, it didn't implement any type of error handling, right? It just had this implementation. And what happens when an exception happens? So there's a scenario where you don't have any network, then you have some problems, and you get an IO exception. And what happens in that case? Well, wherever I use this flow, it will bubble up to my where I create my coroutine. So it will bubble up, and there are two ways that you could handle exceptions with coroutines. One way is to inject into your scope into your context a custom exception handler, global exception handler for your coroutine. And an exception handler, by the way, is so as I told you, context is a set which contains key value elements, and the exception handler is a type of context element. Dispatcher is a type of context element. You could query these things inside of your coroutines, inside of this scope.launch block. You could query those things, and you could do this coroutine context, and using bracket notation like in an array, you could supply a key for it and then query these things to find out what dispatcher am I running on, or what exception handler am I using, etc. So that's one way to do it, to specify a custom exception handler. The other way to do this, the way that I'll show you, is at the level of flows, where basically there's an extension provided to you by on a flow called catch, and it basically catches the exception, and you can re-emit it in a wrapper type. That's what I'm going to utilize. So over here, so when an exception gets thrown, my catch method is going to get called, and I'm going to re-emit it. So I'm doing emit, and then I'm doing result.failure. Failure is a method provided to me in the result class. Results is, by the way, an inline class, and then I'm basically wrapping it with the it there is basically the exception that was thrown. So this catch will be called, and then it will. And when I call the collect on this flow, it will emit a result of failure this time, rather than like blowing up or throwing exception. So how do we test that use case, that code? So first I need to tell my API service, rather than giving me an actual user details this time, throw an exception. And the way that I'm going to throw an exception, I'm using do answer. So if you're familiar with Makito, and I'm going to say throw an exception, throw an IO exception. So and then I'm going to inject into my repo the API service and the dispatcher. Just like as I did before, I'm going to grab the flow like I did before. And then this time when I get the result, I'm just going to do an assertion of assert true. So the way this code runs is that, as I said, it basically goes into that catch block and re-emits the exception, and emits the exception in a wrapper type. And is failure is a method provided on the result inline class. So that's how you handle one way to handle errors, with flows and in your coroutines. So suppose that, rather than this time when an error happens, I want to do a retry with some delay. How do I handle that? And this is a bit advanced. And here in this use case, we'll look at, well, basically, how do we we need more control or virtual time of handling those delays. So how do we do that? So when an API request, when you do the API request, when it fails, I want to retry 2 times. I could retry once, twice. So I'm going to specify it to retry twice. So how do we handle that? So an exception gets thrown. The method that I could use that the coroutines library provides is this retry method, and it has 2 params. The first is the number of retries that you want to do, and the second param is basically a lambda block. It has a suspend keyword modifier, and it specifies under what condition you want to do the retry in. But how do I use this in this flow block? So the way you use this, you're going to call this retry method, and then I'm going to say, hey, I want to do 2 retries. And by the way, that retries is the type is long, and I'm going to say the T is a throwable exception that happened. I'm going to say if there is an exception, then I want to delay by 1 second, and that's the logic that I want my retry to do. So when an exception happens, it goes into the retry, it will delay for 1 second, and then it will go back into this flow block and execute that code again. And it will basically, execute that code, tell my API service, go out to the network, get me some data again after that 1 second delay. And it will do that twice. So we have no code now that handles retries. Is much more robust than what we initially had. So how do I test this? And there are 2 use cases that you want to test. The first use case that you want to test is that all my retries failed. I retried twice, I didn't get any data back. And or one of the retries actually succeeds. Could be the first one or could be the second one. How do I test these 2 things? So what we're going to use is this method called run blocking test, which is what you want to use. This is a method you want to use it whenever you are testing a coroutine that has some type of delays. And it has this ability, I could advance virtual time forward and with it. So when you look at the coroutines library, they provide you this method, and you look at the signature. It has a lambda block, which has this receiver of test coroutine scope, and it creates a dispatcher for me and this scope for me. But I could specify that, hey, don't create a dispatcher for me. I want you to use the one that I made. So that's what that extension does at the bottom. I could say, fun dispatcher dot extension on dispatcher, and it basically grabs that dispatcher and will create a coroutine with it for your test. So I'm going to utilize that. So at the top of my, my test, I've created my dispatcher, and I'm going to do dispatcher.run blocking test, which creates a coroutine for me, and it uses that dispatcher. And then what I need to do, just as I did before, I'm going to tell my API service to throw an exception, right? When the user details methods gets called with an ID of 1. So when I do that, I'm going to grab the flow from my repository. I'm going to start collecting from it. And when I start collecting from it, I'm going to assert failure of I'm going to say result is failure assert true. So I'm basically testing that all the retries failed, and the result I got back was a failure. How does this code, as I've written it, passes? Or how does it run, and why does it pass? So the one you look at, so what happens is that run blocking test, this red dot represents this coroutine that I just created. When I call collect, it will start the execution of the flow block. And then when that happens, basically it goes into this retry because I told my API service to throw an exception. When this happens, it basically delays. When it encounters a delay, underneath the hood, it's basically an event loop. And it's at every time there's a delay, it's basically adding, to this event loop. And it's up to you to basically tell it to process everything in that event loop. It's advanced time forward. And it has the concept of virtual time like underneath the hood. And when you look at the source code inside of run blocking test, it has every time any code that you use with run blocking test at the end, it will call dispatcher that advanced time until idle. Basically advance forward, like, everything in that queue that you're adding it to in that event loop. And when you call this method, it will advance time forward in your test in here. And basically then it will go back in this flow block and retry it again. It will do this twice in our case, which 2 retries. And then it will go into the catch block when all those 2 things fail. And then basically we're emitting the result of failure. And basically we're doing this assertion there. So that's how that test works. Now, one tip I have is that when you look at this code, this right here, dispatcher the advanced time until idle, one of the common errors that I've seen from my experience is that if you, for example, you don't advance time forward, so this could throw an exception and tell you that you have one coroutine which is hanging, because you may have, and I'll show you like use cases for that, or when that could happen. So that's a common problem that comes up. It throws an exception that you have a coroutine that hasn't finished. So finishing, cleaning up your coroutines is very vital. This is learning in this journey of using this. You'll encounter this as I did. So the other thing that you want to test, which is where we need more control, is that one of the retries succeeds. First one might fail and the second one succeeds. How do you do that? So suppose a retry happens and I want it to succeed. How do I do that? So I'm going to basically use these 2 things called pausing the dispatcher. I could, gives me more granular control, and advancing time forward. But I want to advance time forward myself rather than relying on, what's happening underneath the hood. So in order to do that, I'm going to, for this test also, I'll create a coroutine on that dispatcher, using run blocking tests. I'm going to create a flag, and I'm going to set it to true. Basically, this flag allows me to control when my API service will throw an exception or give me back an actual data. So I'm going to basically call, I'm going to create this DTO of user details, and I'm going to tell my API service basically that, hey, in the do answer, the logic that I have is that if throw error is true, I want to throw an IO exception, or if it's false, give me this user details, and I could use this flag to basically control what my API service gives me back, what it does. So that's the advantage of, that's why I'm creating this throw error flag. And imagine I moved all that code out into this mock API service method, but keep in mind, like in the back of your mind, that you have this flag called throw error. So I didn't include it on this because I don't have room in the slide. So And then I'm going to use this pause dispatcher method that I want to eagerly start coroutines. So, and inside of that Lambda block, I'm going to grab the flow, and then I'm going to launch a child coroutine basically there. And this is how you launch a child coroutine. And basically inside of there, I'm doing my flow collection. So now I have two coroutines. One is doing the flow collection, and the other one where I'm going to be advancing, where I'm controlling virtual time. And I have a consumer there. So when that flow.collect gets called, it will start executing everything in that flow block. It will tell the API service to get me something. Remember, keep in mind, right now it's going to throw an exception. And when it throws an exception, it goes into retry, it goes into that delay. Now it's up to me to advance time forward. And I'm going to call that method advanced time by. It will call that advanced time. This advanced time by method is a method on a dispatcher, and it will call it on the dispatcher that I specified at the top, dispatcher that run blocking test. I'm telling it to process what's in your event loop advanced time by 1 second virtual time. And then when it does that, it goes into this retry block and then goes into delay again because my API service is throwing an exception. And now what I want my API service to do when I go back into my flow block is to actually give me some data. So I'm going to use that flag and say throw error equal false. And then I'm going to advance virtual time again by 1 second. So what that happens is that it goes into that retry. And then basically now this time, rather than throwing an exception, give me actual data. And basically now I'm going to re-emit it. I'm going to emit it with the result of success. So my second retry succeeded and my first one, failed. That's what I'm trying to test here. So, and then when I call collect and there's it success, assert true will be, it will pass the test. So that's how you test, retries. Though this can get complicated. Anytime you're testing retries, and you're with your coroutines, anytime you have delays in your coroutines, it can be very challenging to write tests for it, and even with with this. So, but yeah, this is how you would do it. So we have tested our repository and made it robust, and we tested these 3 cases. Now, how do I test basically my view model where I'm consuming this flow? So my view model, as you saw, is like this. The view model basically is responsible for getting the data from the repo and giving it to some reducer. And how do I test this? So one thing to note is this view model, it launches on the main dispatcher. So the coroutines library, as I said before, provides you with the Android specific support, and provides you with these methods called dispatcher.setMain and resetMain. So you could set your own dispatcher using these methods. And the common pattern that's followed in the community is to create a test rule. And inside of this test rule, I'm creating my own dispatcher using test coroutine dispatcher constructor. And I'm then this starting method gets called before your test starts. So I'm just basically in there, I'm setting main to be this dispatcher. So, and then when your test basically tears down, this method gets called where I do my cleanup. So how do we use this rule across all our view model tests? We could use this annotation get rule. And I'm using JUnit 4 here. I use JUnit 4 for my tests right now. So, and then what I need to do is create, mocks from my repository and my reducer, also called state manager if you want. So I'm injecting it into my view model. And then in order to do the test, this time I'm going to create a coroutine. I'm going to grab the dispatcher from the rules because I'm going to say, hey, create a coroutine with the dispatcher from that rule. And then inside of that Lambda block, I want to do my test. So I need to give in. So I have my mock repo, and I need to find a way to tell that repo, hey, to sub it out in a way to give me back some data, so that I could do verifications. So I need to trigger flow collection in my test. So how do I do that? So what I'm going to use is this concept. One way to do it is to use channels. If you're familiar with RxJava, you could similar to subjects, or it's another way to think of it similar to a blocking queue. and it has a cache inside of it, and there are different types of channels provided to you by the coroutines library. And what makes a channel different than a flow is that you could send things to a channel and you can receive things from it. And there's this concept of channels are hot, hot. They're hot streams, and so you could send things to it and receive things from it. And that's in my test. I'm going to utilize that to trigger flow collection. So how do I do that? You could also bridge a channel to a flow. You could do channel.consume as flow on a channel. So and that will give you a flow with it. So how do we use that? So I'm going to test basically that my view model gets data from the repo and gives it to the reducer. How do I test that? So first I've created a user details DTO, and I've created a result class, a result.success with that DTO, and I'm going to create a channel. Now, what is the type of channel that I'm creating here? So I'm creating a channel which has the type of data that I could send to it as a result. I'm specifying with that generic. This is called a rendezvous channel. What makes a rendezvous channel special is that when I send something to it, it will basically suspend the coroutine that you used it from, and only it will only unsuspend it when there's a receiver that receives it, and that's how it functions. So not all channels function that way. The other types of channels, like a buffered channel, has a cache at the end underneath the hood. And there are array-based channels where you can specify how big the cache is. You can send things to it as much as you want. It won't suspend the call in the coroutine that's using it until it's full. So, but this is a rendezvous channel that has the behavior that there has to be a receiver that's receiving what's inside of that channel. So I'm going to convert that channel to a flow, and I'm basically going to have my repo return this flow, and I'm going to use that channel to send things from it. When I send something from the channel, the flow collection will get triggered, basically. And that side of that flow, when you call collect on it, it will basically give me some value data back. And so I'm going to create a consumer, and I'm creating a child coroutine here with channel.send with some result. Well, one thing to keep in mind is that why do I create this child coroutine? So if I didn't create this child coroutine, if I didn't have that at all, and just had channel.send, as I said to you earlier, it won't work. It will basically hang my test, because when I call that send, basically it will hang this coroutine that I'm running, that doing that send on. So it has to be another coroutine which is receiving it. So I have a producer here that's basically, this is my producer, and my other coroutine that I have here, second one that I'm creating using rule.dispatcher.run blocking test is the consumer, or what's in the data, what I'm sending to the channel. So when I call the get user details method, it will basically, I'm going to do flow.collect, and then I'm going to get the data that I sent to the channel, right? And then when I get it, and then I'm going to verify that my state manager actually gets, the dispatch gets called with that result. Well, this is a very simple test. This is one way to test this. So, the benefit of this test is that it shows you, teaches you about channels, and how to use them and what different types of channels there are. So that's how you do. This is a simple case. This is how you test a view model and a repo, how you test retries, and how you test errors. These are things that, these are tests that I've implemented in my experience, and from learning about coroutines, that I'm just wanted to share with you. So the other thing that I want to share is that how do you do flow assertions? So when you looked at all the tests that I gave you, and I called terminal operators on my flow, collect, single, which start the flow collection. So, but if you're using like RxJava, and you may have, there's a method that they provide, RxJava for testing has a method called test on an observable, gives you back, what that observable will emit. And is there something similar you with flow assertion? So I like to look at the patterns that are used in the community. There are a lot of creative things that people do, and one of the patterns is used in the SQL Delight app and by Square. And this is a really great library for SQL. And the way they do testing in that library is very interesting. where any flow that you're testing, they basically all of the emissions, like these, which are represented by these dots, are stored in a channel, unlimited buffer channel, and the unlimited buffer, but it provides you with an API to query what you're sending into what's in this channel. Like you expect an item, if the channel is empty, that means that all you have basically read everything from the channel, everything in the flow is emitted. So you could use the method expect complete. If there's an error, it also handles that. And the way it works is that everything that your test flow is emitting, basically there's an event associated with it, right? An item, for example, suppose your test flow like emits an item, and it goes into the channel. What gets stored into this channel is an instance of item in this case, right? It creates it and wraps whatever that item is that it emitted. Or if everything was emitted, right, at the end of your flow emission, it adds in an event of complete. And if there is an exception, it basically adds in an event for that also. And I'll show you the implementation for that. That's in the library. There's an extension that they provide you with the flow, and it has basically a parameter, which is a lambda block. And what it does inside is that it creates a coroutine. This is another way to create a coroutine using coroutine scope. This is called a coroutine scope, the flow coroutine builder. And inside of there, I'm creating basically a channel with events. So channels, so one thing I didn't say before is that, how our channel is implemented underneath the hood, but it uses a doubly linked list is based on a paper in academia. It uses locked-free algorithms underneath the hood. And so I'm creating an unlimited, channel in here, unlimited cache. So, and then next thing that it does is that it launches a child coroutine in there, and it calls collect on that flow. And you start collecting from it, and it's basically sending things to this event. It's sending items to it, and as I showed you before, and in the diagram, when the flow collection completes, it sends the event.complete to it. And also, like the way it tracks for exceptions is that it wraps it in a try and catch, and wraps the collect call in a try and catch, and when exception happens, it basically sends an event of error to the channel. And when you look at basically the signature of the param, when you look at the param, you can see the receiver is flow assert. The purpose of adding the receiver is that it gives you a really DSL-like, API. And what is the flow assert class? Basically, that flow assert class gets instantiated right here, basically at the bottom of this code. And it basically gets instantiated. It's given this events basically channel, and it provides you with these methods to basically query that channel, everything that's been added to that channel. So if I were to use this, like for this presentation, the use cases that I showed you look like this: flow.test, expect item, assert equals. I could do assert equals your details. If it was emitting another item, I could do expect item call again in here, as many as I want. And if it's emitting an error, I could do expect error, and I could assert like it's a type of IO exception, etc. And that's I really like this approach because it gives you a nice, really fluent API for your testing. So this is the pattern used in the SQLite library. It's not a pattern that which is in a separate library yet, but there is an issue for that. And interestingly enough, just yesterday, there was a comment left where they are working on implementing it moving this into a separate flow assert library. So, which is great to see. So that's one pattern used that's used in the community. There's another pattern that's used in the community that I don't have time to share, but where you could create your own, flow collector for testing. But you could look at that pattern in their open source repos that have that pattern. So interestingly, so the last thing that I want to share is the pattern used in the coroutines library itself. The best way to learn coroutines is to look at the tests that are inside of this repo, and you do that for fun, and it's fun. So I'll show you an example of a test in the coroutines library, and this is an example of it. And this is a simple test, which is testing that the coroutine starts and finishes. And there are interesting things. And what's just interesting about it is that underneath the hood, it doesn't utilize run blocking testing like everywhere, and it uses a different pattern, which is interesting. So I like to look at different patterns. That's why I'm presenting this. So I find it interesting. So there has a method called expect, and it has a method called finish. How does this test work? So the pattern that this is using is that that you'll see when you look at the test in the coroutines library is that I could assert the sequence of execution, I know, in my test of the coroutines, what's happening in there, using this expect, using the index that I pass into that expect method. So it has a finish method to like assert that your coroutine finishes. So, and you also see here that all your tests, like they all extend this test-based class in there. So what is a test-based class? A coroutines library is multi-platform, right? And that's the future of Kotlin, for everything to be multi-platform in the world. So it provides support for JavaScript native, JVM, obviously. So this test based the way it provides multi-platform support is that the test coroutines library has a common module, and it has this definition. It looks very similar to an interface, and it has this expect keyword. And any platform that you want to support, whether it's JavaScript, native, or JVM, you have to provide implementations for these stubs, or otherwise you'll throw an error. It will throw an error. And when you look at this test-based class, it has these methods. It has a lot more things to it. It has these methods that all the tests use: error, expect, finish. It has a method to run your tests called run test. So it has implementations, for this in the 3 different modules. It has implementation for the test-based class. And if the run test method and this gets called, that it's using an example that I showed you. Internally, what does it do? It basically launches a coroutine, and it takes in a block, a lambda block that you want your logic to run in, or your test to run in. And it basically also gives, as I showed you earlier in my presentation, a exception handler that I spoke about. It's a type of context element that it provides. And the reason why it provides, and there's a lot more code I didn't put on the slide that this has, is that it does this to track, the exceptions that are happening. You can do assertions on that too. So inside of there, so the way this works is that this runs on a using run blocking tests. It launches a coroutine and it calls this expect method. And when that gets called, it has in that test-based class an atomic integer for it. It gets incremented away every time you call expect. And so when you call increment.get, it will just give you the current index, and then it will increment it. So it does an assertion on that. Was the index equal to the previous index? And this is how when you call finish, that's how this works. So for finish, it has an atomic boolean that it sets. If you were to call finish again twice in your test, it fails because you already set it. So that's an interesting pattern that the coroutines library itself has, and that it uses, that I find interesting. So lastly, everything that I just shared, you could go to my website, codingwithmohit.com, where I have a blog post on what I just shared here on unit testing, delays, errors with flows, and also have much more in-depth explanation of the pattern used in the Flow SQL Delight library. Also gave a lot of presentation before on if you want to learn about the basics and what happens underneath the hood with channels. You could check out my presentation called Channels and Flows in Practice, and on cpreacherdeck.heyitsmohit.com. Hey, it's Mohit. You can also see presentations on what is a context and how is that implemented underneath the hood. There's a presentation called Dissecting Coroutines that I gave. So those are all things that I learned from just teaching myself coroutines. That's my presentation. I hope that was useful. Lastly, I want to say that I'm really thank you for this opportunity to present at San Diego Meetup. Thank you to Ian, to everyone here for listening to me. Thank you.